Hi guys, I'm going to do a couple more examples on unit dimensional analysis. These ones will be a little more complicated. So in this question it asks, how many grams of lead is 6.0 times 10 to the 3 grams of blood if the lead concentration is 0.62 parts per million? Okay, so we want to begin with our extensive property. And we have mass and we have concentration. I don't want to say mass, that's extensive. What we have here is an intensive property, a concentration. And we'll see that intensive properties are actually conversion factors in themselves. So begin with your extensive property. 6.0 times 10 to the 3 grams of blood. So we want to get from grams of blood to grams of lead. And to do that, we'll need a concentration. So I want to turn this concentration into a conversion factor. I want to multiply. So it's parts per million. So for every million grams of blood, there's 0.62 grams of lead. So I want to get grams of blood canceling. So I'm going to put at the bottom, a million grams of blood for every 0.62 grams of lead. It's simple as that. So all you have to do is multiply it out, grams of blood cancel, and it gives you a number in units of grams of lead, which it's asking for. And our answer will be 0.00372 grams of lead, which turns into 3.72 times 10 to the negative 3 grams of lead. Actually significant figures, I'm just going to take that 2-way. So that's the answer to that question. Our next example is a little more complicated. I really like this question. Canadians combined drive 4.0 times 10 to the 9 miles per day, and their vehicles get an average of 20 miles per gallon of fuel used. For each kilogram of gas that is burned, 3 kilograms of CO2 is produced. How many kilograms of CO2 are emitted into the atmosphere each day in Canada? 1 gallon of gas weighs about 3.5 kilograms. Alright, that sounds pretty confusing. But if we begin with our extensive property, we're halfway there. So we have miles per gallon, we have kilograms of CO2 per kilogram of gas, and we're going to begin with miles then, because we know that's extensive property. So if we go to the next board, remember this number, 4.0 times 10 to the 9 miles. Okay, so the goal of the question is to find out how many kilograms of CO2 are emitted into the atmosphere per day. Well, we know this. For every 20 miles, 1 gallon of gas is created. So that conversion factor I'll use. So I'm going to multiply for every 1 gallon of gas, you get 20 miles. So our miles are canceling, leaving us in gallons of gas. Now we want to convert gallons of gas to something, and which conversion factors from our question give us gallons of gas to something else? Well, 20 miles per gallon, nope. Kilograms of gas that is burned, nope. But at the bottom, 1 gallon of gas weighs about 3.5 kilograms. That's a new conversion factor. So for every 1 gallon of gas, there's 3.5 kilograms of gas. And we have gallons of gas at the top in the prior conversion factor, so we want it at the bottom to cancel it out. So we're going to choose this one right here. So it's going to continue our multiplication. 3.5 kilograms of gas for every 1 gallon of gas. So gallons of gas will now cancel, leaving us with kilograms of gas. We're really close, guys. All we need is one more conversion factor. So for each kilogram of gas that's burned, 3.0 kilograms of CO2 is emitted into the atmosphere. That's our last conversion factor right there. So we have kilograms of gas on the top of this one. We want to cancel it out, so kilograms of gas needs to be at the bottom. I have to choose this one right here. So let's multiply it one more time. In unit dimensional analysis, the units carry through and they all cancel except for your desired unit, or you did it wrong. So now we cancel it out again. So kilograms of gas cancel, leaving us in grams of CO2. Is that what the question is asking? How many kilograms of CO2 are emitted into the atmosphere? So what is our answer? We multiply it out. We get 2.1 times 10 to the 9 kilograms of CO2 per day are emitted into the atmosphere.